Okay, even though we're doing something a little bit different, we're still doing elimination. Okay, we still want to get it just like we did the other day, where either the x's cancel or the y's cancel. And you can go either way. So we want to eliminate one or the other. But it's not going to be nice and easy. It's not going to have one positive 2x and one negative 2x where they just cancel. So we're going to need to multiply at least one equation to cancel either the x's or the y's. And sometimes even both equations. So if I take a look here at my system I have down here. I have 5x plus 6y equals negative 8, and 2x plus 3y equals negative 5. Well, first of all, I got to decide, should I cancel the x's or should I cancel the y's? Well, when I look at this, what I want to do is I want to try to find either multiples, a common multiple between my x's or a common multiple between my y's. So for example, like if I had a 4y and an 8y, a common multiple would be an 8y, right? I can get these both to an 8y. And usually I want to get one positive and one negative so they cancel. So I would take this first one and multiply by a negative 2, because that would bring it to a negative 8y, which would cancel with my positive 8y. Okay, so that's what I want to try to do. I want to try to cancel one of my x's or y's. So when I look at these two equations, I would probably want to cancel my y's, because I can find a common multiple of 6y, right? I can get this 3y to a 6y. And then I only have to multiply one of my equations. So I want one to be 6y and one to be negative 6y. So for them to cancel when I add. So what I'm going to do is I'm going to multiply this bottom equation by a negative 2. Okay? And I like to write it like this because I have to multiply the whole thing. Essentially, by my algebra rules, I have to multiply both sides by a negative 2, okay, to keep my equation balanced. But really, I'm just multiplying every single term by a negative 2. So that's all I do. I usually just put it in parentheses and put a negative 2 out here, so I know I got to do it to every term. So all I do is take negative 2 times each term. So negative 2 times 2x is a negative 4x. Negative 2 times 3y is a negative 6y. And negative 2 times negative 5 is a positive 10. So now I just replaced this equation with that. And it works because if I do negative 2 to both sides, it keeps my equation balanced, so I don't really change anything. So now I could do my system with these two. And if I take a look, when I add these guys, 5x plus a negative 4x is 1x. My 6y and my negative 6y cancel each other. And my negative 8 and 10 give me a positive 2. So I could just solve for x and then plug back in and solve for y. If I were to cancel my x's instead, let me rewrite this here. I'll show you why I did the y's instead. Because if I were to cancel my x's, think about what's a common multiple between 5 and 2. Well, 10, right? So I have to get 1 to 10x and 1 to a negative 10x. Well, I'd have to multiply both equations then. So I'd have to decide, well, let's make this top one a positive 10x. So I'm going to multiply by 2. And let's make this bottom one a negative 10x. So I got to multiply by a negative 5, right? Because negative 5 times 2x gives me negative 10x. And then I have to replace both equations. So this top one would become 2 times 5x, which is 10x. 2 times 6y, which is 12y. And 2 times negative 8, which is negative 16. And then I'd have to do the bottom equation. Negative 5 times 2x, which is negative 10x. Negative 5 times 3y, which is negative 15y. And negative 5 times negative 5, which is positive 25. And then I could go through and solve my system by elimination. That's why I eliminated the y's. So it's much better to do this first way, okay, because it saves you a little bit of time. All right, so let's try an example, and we'll do the whole problem here. Well, let's take a look. What do we want to cancel, the x's or the y's? I'm hoping you said y's, because if I do the x's, the common multiple between 2 and 3 is 6, so I'd have to multiply by both equations, where common multiple of 1 and 2 is 2. I could just get this first equation to a 2y. And in this case, a negative 2y, because I want the 2y and the negative 2y to cancel. So how do I get this guy to a negative 2y? I got to multiply by a negative 2. So I'm going to write this over to the side. So I have negative 2 times 2x, which is negative 4x. I just multiply every term. then negative 2 times y, negative 2y, and negative 2 times 23, which is negative 46. And then I'm just going to keep my second equation the same because I already have a positive 2y. That'll cancel. And now I go through and add my two equations. Start eliminating my system. So a negative 4x and a 3x gives me a negative x, negative 1x. The negative 2y and 2y cancel, equals negative 9. Well, I don't want a negative x, so really I divide by negative 1 on both sides, which gives me x equals positive 9. It just switches around. Well, we have to solve for y as well, don't we? Okay, so I can use any equation I want. I can plug in 9 to this equation, I can plug it into this equation, I can plug it into this equation, or I can plug it into that equation. It does not matter. Okay, I'm going to go ahead and plug it back into this one up here because I only have a single y to solve. There's no coefficient on that y. So I'm going to plug it in up there. So 2 times 9 plus y equals 23. Well, then I got 18 plus y equals 23, and subtract my 18 from both sides, and it looks like y equals 5. And just like before, every solution is an ordered pair. So 9 for my x, 5 for my y. There's my solution, 9, 5. Okay, so we just have to multiply before we can eliminate. Uh-oh, look at this guy. It's not as nice and neat, right? Before, the x's and the y's were all lined up together, weren't they? So that might be a good idea. Let's get my x's and y's lined up. So this guy looks good. I'm going to bring it over. It's already lined up. So it's good to get your x and y term on the same side. So over here, it doesn't really matter which way you move. I could just subtract this 3x over. So really I have a 23 equals negative 3x plus a 5y, positive 5y. And then I'm going to flip. I'm going to use my symmetrical property and put my negative 3x plus 5y on the left side of the equal sign and put my 23 on the right side. So now I have a system to work with where it's lined up. It's good to get them all lined up. Well, what should we cancel? Should we cancel the x's or cancel the y's? Well, it doesn't matter which one because both of them you're going to have to multiply both equations, right? Because common multiple of 4 and 3 would be 12, and a common multiple of 3 and 5 would be 15. Well, I'm going to do the x's just since one's already negative. Okay, so I'm going to get one to a 12x and one to a negative 12x. So I'm going to multiply this top equation by a positive 3. I'm going to bring that over here. So 3 times 4x is 12x, 3 times 3y is 9y, and 3 times 8 is 24. And we multiply this bottom equation by a 4 because we want a negative 12x. So negative 12x, and then 4 times 5y, which is 20y, and 4 times 23, which is 92. And then we solve our system. So basically, I'm going to add these two. So 12x and negative 12 will cancel. 9y and 20y is 29y. And 24 and 92 gives me 116. So we divide by 29, divide by 29. And that leaves us with 4. Y equals 4. So like I said before, you can plug it in anywhere you want. I'm going to go over here. I'm going to plug in y equals 4. I'm just going to throw it into this second equation. You can put it in anywhere you want. Anywhere you want. So 23 plus 3x equals 5 times y, which we said is 4. And so that's really 20. So 23 plus 3x equals 20. Subtract 23 from both sides. Right, we're trying to get our x by itself. So 3x equals negative 3. And divide by 3, which gives us x equals negative 1. And then our answer is an ordered pair. So negative 1 for x and 4 for y. Box their answer so I can find it. Okay, so sometimes it just takes a little bit of work, a little bit of organizing, figuring out what you want to multiply by to cancel. Lastly, we can set up a story problem with the system. Okay, so you just got to read carefully. Just start writing equations. That's my best advice. Give some variables for things you don't know and start writing equations. Let's read through this. Steve subscribed to 10 podcasts for a total of 340 minutes. He used his two favorite tags, sports and world news. Each of the sports episodes lasted 32 minutes. Each world news episode lasted 42 minutes. to how many of each tag did Steve subscribe? So this is what we don't know. How many of each tag? So I'm going to give the letter S for sports. That's one thing I don't know. And I'm going to give the letter W for world news. Those are the two things we don't know. So let's see if we can come up with two equations. Well, first of all, I know that we had 10 total podcasts. I don't know how many of each, though. I don't know how many sports or how many world. But I know they added up to 10. So there's my first equation. The number of sports podcasts plus the number of world podcasts equals a total of 10 podcasts. Yeah, that's my first bit of information that I know. Well, can we write another equation now? Well, let's see. I know they totaled 340 minutes, and each sports podcast was 32 minutes. Well, if I take 32 times the number of podcasts, that'll give me the total minutes, right? So 32 for each podcast times the number of podcasts, which is S. And then I also know that the world news lasted 42 minutes, so we add that on to each world news times how many world news podcasts we watched, right? So this first one would be the total sports minutes. This would be the total world news minutes, which total what? 340 minutes. So it takes a little bit of thinking there. So you got to define a variable and start writing equations. So anytime I wrote my first equation, I had two variables, an S and a W, so I automatically know I need a second equation to solve. Because if you have two variables, you need two equations for a system. Well, what should we cancel, the S or the W? It doesn't matter. Let's cancel the S. So I'm going to multiply this first guy by what? A negative 32. So I can get a positive 32S and a negative 32S to cancel. All right, so we go distribute. So negative 32 times S, negative 32S. Negative 32 times W, negative 32W. And negative 32 times 10, negative 320. So I just replace that guy with this black one down here. So now let's solve our system. So these cancel. 42W and negative 32W is a 10W. And 340 minus 320 is 20. Divide by 10. Divide by 10. W equals 2. Well, I could go plug back in, but I should know if W equals 2. So I got 2 world news podcasts, which means I have to have, what, 8 sports podcasts? Simply because they total 10, right? They total 10. And if I plug that back in, up in here, I would know, well, 8 plus 2 gives me 10. So there's my final answer. 2 world news and 8 sports podcasts. Yeah, I could do trial and error, but that might take a while. So I just like to set up my system, right? 2 variables, I need 2 equations. All right, so the last thing we're going to learn on our systems of equations.